For the application problems in section 7.2 and for the problems in chapter 8. For the application problems in 7.2 and for the problems in chapter 8 dealing with probability, we are going to use a normal probability calculator that's built into StatCrunch. Since we don't have a data set that we can load into StatCrunch, we're going to go to the question help and we're going to open up a StatCrunch window. And then the normal calculator or normal probability calculator can be found under Stat Calculators and then down to Normal. So this normal probability calculator is actually a friendly tool to use. It gives you a visual picture of the area under the normal curve or the probability that you're calculating, and it's fairly easy to use. So the first thing you need to know about the calculator is this is defaulted to work for standard normal. That is, it is preset with the mean equal to 0 and the standard deviation equal to 1. So when you work these problems, the first thing you're going to want to do is read through the problem and see what the mean is and the standard deviation for this problem. So in this case, it tells us that we have a mean of 56 and a standard deviation of 3.3. So problems in this section can read one of two ways. One is it can ask for what proportion of whatever we're studying meets a certain criterion, or it could ask what the probability of randomly selecting an individual with a given condition is equal to. Both of them we're going to answer using this same tool. So in this case, part A, the proportion of light bulbs that last more than 61 hours. So more than, that would be greater than. The fact that there is an equal to here does not matter. The normal distribution is a continuous distribution, and therefore the equal or not equal part doesn't change the proportion or probability that we get. So I put in greater than or equal to 61 in compute, and on the right side here in this box is my proportion. So the proportion is 0.0649. The next question asks for the proportion of light bulbs that last 51 hours or less. So I change the 61 to 51, and then because it's less, I need to switch the inequality. And so the answer there happens to be the same, 0.0649. The third question here asks us to find the percentage that is between. If we click on the between up at the top, then we want between 58 and 62 and compute, and so that proportion is 0.2377. So then the last question asks, again, a little bit differently, what is the probability that a randomly selected bulb lasts less than 45 hours? So because it's a less than problem, what we call a one-tailed problem, we go back to the standard it's set to less than, and then 45. So the answer would be 0.0004. It is possible on some of these that your answer could be 0.0000. At least when we get to chapter 8 and that, at some point you may have that, and that's okay.